I don't think so, but it doesn't matter. I'll just link it on the Discord. So no one's gonna. I
Or
don't
like
have any
unlisted?
followers. I don't think. I could do YouTube as well, or not as well, like YouTube, and then it'll be private. But you can just log out of your Twitch or go like incognito mode if you don't want to show up on the viewer list.
I don't even have an account.
Oh yeah, then it's fine. You don't need an account. You can just view
I just don't like. Oh.
as well, like YouTube, and then it'll be private. But you can just log out of your Twitch or go like incognito mode if you don't want to show up on the viewer list.
I don't even have an account.
Oh yeah, then it's fine. You don't need an account. You can just view
I just don't like. Oh.
as well, like YouTube, and then it'll be private. But you can just log out of your Twitch or go like incognito mode if you don't want to show up on the viewer list.
I don't even have an account.
Oh yeah, then it's fine. You don't need an account. You can just view.
I just don't like. Oh.
Microphone.
Hey, Alex, can you just put the, or for us, can you put the domain for it in the resources channel? That'd be great.
What domain? What do you mean?
For a certain Minecraft server.
Oh, it's just okay. One sec. On the oh, not on the resources. I'll just DM you. I don't think it's supposed to be public yet.
No.
Oh wait, yeah. Alright. Oh, people are in here already. What the fuck? I didn't realize. We'll start soon. Just give me a sec. I'll just link. I'm using Twitch, so I'll just link the stream
Alex,
in a sec.
can you just put the, or for us, can you put the domain for it in the Amen.
What kind of name is that, James?
Best name ever.
Dude, how the fuck do you turn up mic volume on Windows? This is so stupid. Oh, actually, wait. Cause that probably works. I don't know.
What kind of name is that, James?
Best name ever. Who knows how to turn up Windows? Turn up Windows? Turn up mic? I don't know how to life. Now I can fight with other players?
Dude, how the fuck do you turn up mic volume on Windows? This is so stupid. Oh, actually, wait. Cause that probably
Oh, here's Ben's pixel art.
Okay. I'll link the Twitch. Where do I link it? Voice channel? Yeah, voice channel. That's the link. I'll switch the thing over. One sec. I'll explain what we're doing. In like, I'll just wait like 5 minutes for people to join.
Hey, how do I enable creative, boys?
You gotta tell Alex. Also, we're not playing Minecraft here, so get out. No, I'm kidding. But you know.
Hey, boys. boys. Really, this is just a Minecraft session.
Yeah, we'll just wait. You can like, I don't know. Should I mute this, like mute my mic on the? No, I'm not muting my mic on the stream. But like, should I mute my mic on Discord and you guys?
Discord.
Hmm?
Mute Discord
Okay,
from
okay.
the stream, because if not, it's gonna be really
Oh yeah,
weird
true,
hearing
true, true,
everyone else.
true. Yeah, okay. Actually, but then, wait, how does that work? Cause like, okay, I guess I'll just keep checking the chat, like on the Discord. I
Either
guess.
that, or you just go and be by yourself and talk about it, because if not, we're gonna hear it in the chat.
True.
Or mute us.
I
don't
could
know.
do that. Yeah, Yeah, okay. Actually, wait. Now let me think. Let me think. The hell's a good way to do this? I guess, okay, I'll just mute my headset. I'll keep Discord open. So if you guys have anything to say, just type it in, right? Like in the voice channel. And I'll read it and, hopefully that works out. If that doesn't work that well, no, because if I keep my Discord sound on and you guys talk to ask anything, it's gonna echo back into the stream and it's gonna sound a little weird. And I'm gonna hear it as well, so it's gonna echo. Actually, no, I can keep the stream off, so I can. That's not the point. You guys are gonna hear yourself. Is that fine? Are you guys okay with that? I don't know. Oh wait, I know what you mean. Okay, okay, yeah, okay, okay, I can do that. Yeah, yeah, I'll mute. Okay, all right, cool, yeah, easy. Yeah, I muted my sound on Twitch. Yeah, okay. Cool. Is it laggy? I don't know. Can you guys? Let's see. I'll zoom in a little bit. Can you guys see like the terminal? Someone say something. Hopefully. On Twitch, on Twitch. Can you guys read the text and it's not laggy and it's not, I just linked it above, dude. Above right where you said. Okay, cool. I don't know how much delay there is. Dude, it's like right above Toxic Faith. Alright, cool. What? Oh, I think you... Alright, I don't know what the hell's going on. Okay, I'll give it fucking 3 more minutes and then I'll start, I guess. Just making sure people can join if they want to. I should actually do I do an all? Like add everyone? Should I do an add everyone? Alex, you wanna do an add everyone? Okay, fine. Alright, done. I'll do that as well. Okay. Alright, 2 or 3 minutes from now, I guess, since I just added everyone. Anyway, these are all the challenges. Oh, that is loud. I bet you guys didn't hear that. Someone just followed, I think. I don't know. Yeah, so these are all the challenges. It's a huge list. And this is not even all of them, because, when you finish the challenges, they more unlock, and the harder ones start unlocking. So I won't go through every challenge. I'll find like the ones that are interesting, sort of, and try to explain it as best as I can. And I haven't done any of the challenges here, so this should be fun, interesting. Hope. Yeah, I will wait 2 or 3 minutes, and yeah, let's see. Actually, I think we have enough people, so I'm just gonna get started. Hey everyone, so today we're gonna look at, or I'm gonna sort of do a stream, and it's gonna be me going through PicoCTF challenges, specifically the 2018 ones. I haven't played the CTF yet, so I mentioned this in the announcement I made yesterday. But essentially, what a CTF is a capture the flag event, right? So these are sort of cybersecurity hacking contests or games, if you will. Essentially, they give you a bunch of challenges like these. Actually, I'll zoom in a little bit so you guys can read it as well. Or you guys can go to this link. I'll put it in the chat on Discord. You can go to this link. You have to create an account and verify it. So you don't have to do that right now if you don't want to. But essentially, you have all of these challenges, right? And you solve them. It's essentially they teach you hacking, sort of. So PicoCTF is a very beginner level CTF. So you essentially do these challenges and they're very easy, but they get really hard. And when you do them, you get what's called a flag. And the flag, you submit it here and you get the points for the challenge. So for example, forensics warm-up 1, 50 points, which is pretty little, and it has 45,087 solves. So essentially, this is what we're gonna go through, or I'm gonna go through. You guys can follow along if you really want. I'm on Linux, and it's best if you're on Linux and you have like a terminal that you can use, because Linux terminal is essentially what you use for CTFs most of the time, unless there's a Windows specific challenge, which I don't think there are any in this CTF. Some of the challenges you will be able to do on Windows, but it's just easier if you use Linux. Plus you're learning Linux at uni anyway, so why not, right? What happens if you're on Windows? Yeah. Okay, now I'm just gonna ignore the chat for a little bit. So let's just get started, right? Forensics warm-up 1. Can you unzip this file for me and retrieve the flag? I spelled retrieve wrong. Hints, make sure you submit the flag as PicoCTF, blah, 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 right? So unzip the file. I copy that link. I'll cd, I think I have a CTFs directory. I'll do PicoCTF 2018s. Let's make dear forensics. I'll just make a category for it. Make dear warm-up 1, and let's go. wget the file. That's annoying, that thing up there. It's stuck, but I just essentially wget the file. It won't let me wget it, so I actually have to download it directly. Download it. I'll move it from downloads to here. Unzip flag. So this is just Linux command line stuff. I mean, I do like understand some people won't have, you might feel a little confused with me typing all these commands. So if you actually do feel that confused, just mention it, or just unmute your mic and tell me, and I'll explain it again, or sort of. Okay. So yeah, I unzipped it. There's a flag.jpg. So I'm assuming that's, I'll open file thingy viewer. Where is it? Home CTFs. Oh, wrong one. Assume I just opened the flag, and okay, so this is a very basic one, right? So they're just getting you to do it. So it's welcome _2 forensics. All right, we'll just submit the flag. It is pretty basic. So it's gonna be PicoCTF welcome to forensics. Should be easy. That is correct. All right. So second one. For some reason I can't open this PNG. Any ideas? I'll save this. Again, same thing, go back, make dear warm-up 2, that's a challenge. Downloads. What the hell? Oh, MV. I'll move this here. So this is flag.png. I'll go files again. Warm-up 2. Alright, I'll try to open this. Could not load image, flag.png. Now, I sort of know how to do this challenge already, because I've done a billion challenges like this before, but I'm going to go through how I do it. So if I didn't know how to do it, so I'll just go back to the challenge. I'd click hints. How do operating systems know what kind of file it is? It's not just the ending, right? Okay. And make sure you submit the flag as PicoCTF, blah, blah. Okay. Cool. So how do operating systems know what type of file it is? If I do file flag.png, oh, look, it says, okay. So file is a Linux command that tells you what type of file it is, and the way it knows it is it looks at actually I'll actually go to this and open up Magic Bytes file. Let's see. This should be a Wikipedia page somewhere about this. This is probably okay. So I'll explain what I mean. So if you open a file, so this is like a JPEG image, obviously. If I open it in Vim, for example, you'll see it's a bunch of random stuff, but at the beginning, you'll always, for a JPEG file at least, at the beginning, you'll always see this sort of string for every single JPEG file. All right, and that's JFIF, for example. Here, if I go back to the Wikipedia page and I search for JPEG, you'll see here it just shows you the same thing. This is how that file command that I used. I quit again, so if I'll just file flag.png. This is how the file command knows that this is a JPEG image, right? Except the image viewer itself doesn't know this, because the image viewer isn't that smart. It uses the extension at the end to determine what type of file it is. So the way to open it in the image viewer would be to just rename it to flag.jpeg. Is it JPG or JPEG? I'll just go with JPG and open it again. Oh, it worked. Okay, so extensions are a lie. All right, again, it's pretty simple. So, what is it? Yeah. So that's essentially, that's not the one. It's this one. Welcome. Oh, extensions are a lie. Submit. That is correct. All right. Now this is something everyone should know, because we all did OOPD, I hope, and we should all know what this is. If I told you your grade was hex 41 in hexadecimal, what would it be in ASCII? So, I'm just gonna do it like mentally. Oh, JFI. Okay, I'm just gonna do it mentally. It's 16 times 4 plus 1, which is 64 plus 1. That's 65, and I assume it's gonna say, if you're Ish, you have to submit it in this format. So it's gonna be PicoCTF 65. That is in what? Okay, hold up. 16 times 4. Oh, okay, that's a capital A. Okay. Oh, true. All right, yeah, it is. Okay, so hex 41 in hexadecimal is capital A. The way you figure that out is to go ASCIItable.com. You look for hex here, hex 41 right here. I'll zoom in a little bit. So hex 41 is A right here. So that's that. I'll actually put on some music as well, because I'm assuming a lot of people are listening to this stream. Let me see. Put on some lo-fi. I don't know. Let's see. Actually, what sort of people would like? What sort of music would you guys like? I don't even know. No. Just this like chill music. Lo-fi beats to study to. Alright, let's go. Spotify lo-fi beats to study to. Yeah, there we go. I'll just play this. And I'll put it on fucking shuffle as well. How's the volume? Tell me if it's... Oh wait, I need to... Okay. Alright, I'm just gonna turn on stream audio as well. Why not? Just tell me if it's like too loud or not loud enough, and I'll just wait a little bit for you guys to tell me. Alright, cool. Alright, let's move on. Can you convert the number 27 base 10 to binary base 2? I guess you can just cheat here a little bit, because I cannot be bothered doing this conversion. So 27 in binary. It doesn't really matter if you cheat. It's 11011. Alright, so it's PicoCTF 11011. I'm gonna skip this because you're one of your team. Okay, I'm gonna just skip this. Can't be bothered. Actually, I'll tone the music down a little bit because it's too loud for me. Okay. We put together a bunch of resources to help you out. You might even find a flag here. Alright, let's go to... They put up a website for this, so we put together a bunch of resources to help you out on our website. If you go over there, you might even find a flag. So we come here, resources, blah blah blah. Thank you for reading. Here's a flag for your time. 2019 competition. Okay, we're doing 2018, so that's pretty easy. You can't hear the music. One sec. Okay, I'll turn the music up. Is that good? Okay, is it too loud now? Okay, I'll just turn it down then, because it is too loud for me. Okay, sorry, yeah. Alright, I turned it down. Okay. Yeah, so that was pretty easy. Again, for everyone that just joined, or that joined after I started, I'll just real quickly reiterate. So this is PicoCTF, which is a very beginner level CTF. Usually when you start in cybersec or just in general, anything computer related, PicoCTF happens once a year. It's got very beginner level challenges, as you probably realized, but it does get pretty difficult, as we'll go down the list, you'll see. So yeah, essentially you solve the challenges. When you solve the challenges, you get what's called a flag, and the flag is essentially a string. And in this case, it's gonna be of the format PicoCTF, something in the middle, and you close it off with another curly brace. So that's a flag. So for example, I'll just do this because I'm talking now. What is hex 3D in decimal base 10? So this is 16 times 3, which is 48, plus D is 13, so that's 61, I think, unless I just did that wrong. Okay, yeah. So essentially that was easy. You just convert it and do the flag format. Yeah, we just did this, right? Where did that go? I think I copied it. Yeah, okay. So this was at the link. I'm not even gonna go through that. It's pretty easy. Okay. Reversing warm-up. This might not be that interesting, but the second one might be. So reversing warm-up 1. Throughout your journey, you will have to run many programs. Can you navigate to this directory on the shell server and run this program to retrieve the flag file? Okay, I'm not going to download that because it's going to be on the shell server. So the shell server is up here. You click the link, open in a new tab. You have to log in, I believe. Hopefully it shows up. All right, there we go. I'm Faith, so I don't know if all caps or caps matters. Okay, I have to reconnect. Actually, I think caps matters, so I'll just go with that. And ask for my password. Okay, what the fuck is going on? Okay. That did not work. Did I forget my password? I didn't forget my password, right? I might have forgotten my password. Okay. What is my username? Oh, okay. I fucked up my username. No wonder. All right, there we go. That should work. Forgot what username I had. All right. So this is essentially a shell in your browser for PicoCTF. So they give you a directory to go to. It's this directory right here. So we cd into it. I assume you paste like this. Yeah. So paste it. Go into it. ls. Okay, I typed it in wrong here. So you just run like that, and I assume it just gives you a flag. Yeah, okay. PicoCTF, welcome to reversing. So again, this was very simple. It's just to get you into their shell server, because remember, this is a very beginner level CTF, and it's for high school students mostly. So they get you into the shell server, and now reversing warm-up 2. Can you decode the following string from base 64 format to ASCII? So I don't think PD would do much for it. What do you mean? Okay, are you guys talking? Okay, never mind. So, okay, can you decode the following string from base 64 format to ASCII? So what is base 64? What sort of hint do they give you? Okay, so base 64 is a format that you can use to convert. Okay, so when you say encode or decode, what it means is, I'll use that example with the flag.jpg, right? So if I go flag.jpg. Oh, okay, it won't even let me. Okay, so you can see there's a bunch of characters here that aren't actually, like, not readable. They're not ASCII characters, right? So that's why they look all weird. Like these characters here, for example, they're not ASCII, so they show up weird. So what happens with basic? So what happens? Well, if I wanted to copy all of this data here and then send it to you, right, over Messenger or over any text, right, I wouldn't be able to do it, because if I copy all of this and I paste it in Messenger, it wouldn't show up because it's not printable, right? These characters aren't like this, for example. This is one character. This 8F, the bracket, this is all one character, and it Vim prints it, but Messenger probably wouldn't. So I can't copy paste all of this to show it to you guys. What I can do though is encode it. So when you encode it, all of the characters that are non-printable become printable. And one of the encoding formats that you can use is base 64, and the way you do it is first of all I can cat the flag.jpg, right, and it's just gonna output all of the text, right, and it looks weird, right, but I can also do cat flag.jpg and pipe it into base 64, right, and that gives you, as you can see, this is all printable characters, right, so it encodes all of the non-printable characters into base 64, essentially. And now I can send all of this to you, and you would be able to, if I can, actually I'll just scroll down. I'll try to see if I can copy all of this, unless it's a lot of, unless it's too much. Yeah, it is too much, okay. So if you wanted to, you could have copied all of this and decoded it, which is what I'm gonna do with the challenge. So challenge gives you this text. And the way to do it is you can do echo -n, so it removes the new line, because otherwise it's just going to have a new line at the end here. You don't want the new line. So echo -n that, and then you pipe it into base 64 -d for decode, right? And that just decodes it, and it just says that was simple. So that's easy. That's the flag. That's essentially what base 64 is used for, or any encoding format. There's also hexadecimal encoding. There's a bunch of different encoding formats, but that's essentially what it's used for. You have to wrap the flag around PicoCTF like that and submit. All right. Hopefully that, yeah, that's correct. All right. So, crypto warm-up 1. Crypto's kind of fun. Crypto can often be done by hand. Here's a message you got from a friend with the key. This is a little key. Can you use this table to solve it? What is this table? Okay, I'm not gonna open with. I'll just download it. Go back again. Make p crypto / warmup1. Download the table and move it here. I'll open the table in Vim. Okay, so this is what's called a Vigenère cipher. I know this because I've done it before, but if you didn't know, I think the hint actually tells you. I'll look at it. Some of your answer blah, blah. Okay, please use all. Okay, it doesn't tell you. But when you see the table like that, I guess they give you these two. I'll copy these and put them down here, so we know what we're looking at, right? Also, if I'm going too fast, just let me know. I'll slow down, right? So this is the message they give you. I'll actually put message and key. So this is the message, and that's the key. And they give you this table to figure it out, right? So this is, again, like I said, it's a Vigenère cipher. You would have been able to, you probably would have figured it out. You should just Google a list of ciphers, right? And you'd probably find this sort of thing. And a Vigenère cipher is essentially a big, that's a bad image. It's a big table of characters that you can use to translate. Is it Vigenère? I don't know. I don't know how you pronounce it, dude. I don't know. It's French. I'm not French. Vigenère? Okay, I'll go with Vigenère. Okay, this is a Vigenère cipher. That's, you use a table, and it's sort of intuitive, actually. So, for example, the message starts with an L, and the key is a T, right? The follow sound might be loud, I don't know. Either way, I'll ignore it. The message starts with an L, and the key is a T, so you can sort of guess how it works, which is what I did the first time I saw Vigenère cipher. So you go to L, right, and you like go down until you meet the character that it matches with, so it's a T. So I'll start with the L here, you go to the T, and you scroll left until you get to the other character, and that's the actual message, right? So I'll do cipher, actually. Cipher text. Do that, and plain text. I'll do, so that's an I believe, right? I'll double check real quick. Yeah, it is. It's an I for the first one. It did say all caps, I think, in the hint. Yeah, please use all caps for the message, so I'm just going to use all caps while I translate. So yeah, you just, it's a bit tedious, but you just do that. So LH, again, go down until I find the H right here. So that's a W, it's not there. Again, I'll just do this real quick by hand. I into K into I. Actually, this is sort of tedious, hey, but there are a good couple crypto challenges down the line, so should probably do this right here. Y, JS, OJ. That does not look right. I'm sure I don't have a script for Vigenère. If you guys have one, then yeah, go for it. Like, let me know what the flag is. I can't be bothered. Actually, like, cause I'd have to. Yeah, I can't be bothered scripting this up. Actually, should I skip this? I don't know. Do you want me to skip this? I'll just keep going until someone says yes. I to M to I. Okay, okay, I'll skip it. Whatever. All right, cool.
Script, not skip.
No, I know. I heard you say. Okay, should I? Okay, fine. I'll make a script. Let's see. Let me look at the table again. I'll make a quick Python script. So it just goes A B, okay, and it just goes A to that doesn't look that hard. Yeah, okay, I could do that, I think. Yeah, okay. So I'll use Python. Hopefully people here know Python. Do I have Python 3 installed? Yeah, I do. Okay. So I'll just do solve.py, I guess. I'll do shebang Python 3, so that works out. Okay. I'll have to plan this out a little bit. So we have our let me think. So A, let's see. Hold up. What's the best way to do this? Yeah, I'm gonna have to actually think about this a little bit because it's a 2D table and I need to get A to Z, then B to Y, and then Z wrap around, and it is B to Z and then A wrap around. No, you can't just strip the characters, you have to add it to the end as well. That's why that's annoying. Now, I know how to do this. It's just, you know, it's just I have to fucking think about how to. Okay, let's just start, right? So I'm gonna build a fucking. I'll just do it the best way I can think of, and go X is equal to A B C D F G H I J K L M N O P Q R S T U V W X Y Z. I'm not the best at Python, so I'll just do that. That's the top. Let's just say the top row, and I need to map these characters to each other. So A maps to, I'm gonna actually SP, not SP. What is it? VP? No, not. Fuck. How do you do a vertical split in? VS. Okay, there we go. I'll open etable.txt here, so we can do this. So A maps to A maps to B, A maps to C. Alright, that's easy. Do you guys want me to skip this, or I don't know? It's up to you. Just tell me. I'm gonna skip it. Like, vote. You reckon this is good content? Alright, I mean, I'll figure this out with you guys if you want to. I don't know. Don't troll. Like, literally, do you guys want me to skip this or not? I'll skip if you guys want me to. So people saying no and people are saying yes. I don't know. Alright, tell you what. I'm gonna skip. Just because. Yeah, it is. I'm just gonna skip. I'm just gonna skip this. Whatever. Alright. Crypto warm up 2 is here anyway, so. Oh yeah, true. I can just Google. Yeah, true. Vigineer script solver, whatever. Alright, I can just Google this. Yeah, right. There we go. What is the ciphertext? It is this. So yeah, you can actually do this as well if you. But writing the script would help, like learn. But you can do this and the key. That's the alphabet. Where's the key? I know the key. The password. This is gonna be. This is a little key. Right. That was the key. Decrypt, and it tells you. The answer is secret message. So I was doing it wrong somehow. I don't know how, but alright. So you have to wrap it around. I think you have to go you don't go from top to left. Oh, I did it wrong. Wait, it has to be all caps. No, I think instead of going from top to left, you have to like start on the left and go up. That's probably what I was doing wrong. I don't know. Alright, that's correct. Alright. So cryptography doesn't have to be complicated. Have you ever heard of something called ROT13? Okay, ROT13 is essentially, if I Google it, you take each character and you rotate it by 13 on the ASCII table, right? So this is, again, if I take this and I put it in there, it's gonna solve it for me. But essentially what it's doing is, where's the ASCII table? So if I say I have a D, ROT13 would add 13 to it and go up to 91. So that right there. So that's just ROT13, right? So I'll just cheat a little bit because this is pretty easy to write a script for. So PicoCTF, this is crypto. All right, grep 1. Can you find a? Okay, I'm gonna skip that. That's actually annoying because actually nah. Okay, since I have the shell open anyway. So essentially, can you find the flag in file? Okay, this would be really obnoxious to look through by hand. See if you can find a faster way. You can find the file at here on the shell server. So I'll just oh, it's lagging. Go there. So that's file. If I cat the file, I'm assuming it's a shit ton of text. Yeah, okay, it is. So what they want you to do is find the flag, right? And you know the flag format is gonna be PicoCTF this, right? So you can use grep, which is the name of the challenge. It is a Linux command line tool that lets you search, right? So I can do grep. I forgot the syntax. I believe it's search text first and then the file. So I'm just gonna go PicoCTF that, or I need to do that because that's a special character in grep syntax. So I have to backslash to escape it, and then the file, which is a file. Okay, unmatched. Okay, that's not. I think you have to actually use single quotes instead of backslash like that. Okay, I'm just gonna do PicoCTF because that's gonna work probably. Oh, file. Oh, actually, I'm just gonna, yeah, okay, file. Yeah, there we go. Okay, grep, and you will find this, right? So that's the flag. Again, it's just searching for the string PicoCTF in the file, and you can see the file text is huge, right? You don't want to be like manually searching. You can find it if you manually search, but like grep's easier. So, oh, that didn't copy. What is it? That doesn't copy. Huh. Okay. Control C. Okay, that works. Alright, that is correct. Alright. Using netcat will be a necessity throughout your adventure. Can you connect to this at port 36356 to get your flag, right? Alright, so netcat is a tool that you can use to connect to ports on like remote servers. So that's not the IP, that's the address of the server, and that's the port 36356. I'll quit Vim. So netcat is NC on the terminal. I think I have it installed. Yeah, okay, so it just should be installed by default. So NC, that thing, and 36356 I believe is the thing. And yeah, okay, so that wasn't so hard, was it? And so yeah, netcat can be used to connect to an address at any port, right? So a port is what hosts a service. So for example, this website is running on port 80, right? So port 80 is the default port for a website, right? And you will just know this if you just like Google default HTTP port, right? So default HTTP port is 80. HTTP is used to host websites, and therefore this is hosted on port 80. This is a very high port. In order to connect to it, you can't just use a web browser. It wouldn't work. So you have to go through netcat to specify the port, and it gives you the flag. So there you go. Again, like as I said before, you use this to sort of get a baseline level of knowledge that you can use later on. So like for example, you now know about netcat, so if you ever run into an issue with, I don't know, you need to connect to a specific port, you won't just get stuck like, oh, how the fuck do I do that? Like you just know, okay, this is netcat, this is how you do it. Yeah, so hopefully this starts getting a little harder soon. Okay, so should I slow down? I don't know. You guys are saying going too fast, I don't know. Okay, so we found some important looking files on a Linux computer. Maybe they can be used to get a password to the process. Connect with this to that. So again, you have to use netcat, pretty sure, yeah, because it gives you the command. The files can be found here, password in shadow. So okay, I'm not gonna read the hints. Files can be found, should I download them? I'll just connect first. Let's see what happens if I use the command. Username, wait. Okay, I do have to download the files because I'm assuming this is going to be a password cracking one. So I'll download password and shadow. I'll explain what these files are in a sec. So I'll go, what is this? General skills, cryptography. Okay, crypto, what is it called? Here's Johnny, make your Johnny. MV download here. Okay, so we have password and shadow, two files. Okay, cat shadow. Okay, so I'm gonna actually cat password and echo. Okay, yeah, that's better. And cat shadow. So this is the password file. This is the output from the password file. And what are you guys saying? Okay. Now I'm actually gonna go through everything. Don't worry. So this is the output from the password file, and this is the output from the shadow file. So on Linux, if I do ls -etc grep for password or shadow, that doesn't work. Grep for password and grep for I don't know what. Okay. All right. So what the fuck? All right. So on Linux, you have these two files, right? So one is /etc, so it's /etc/password, and the other is /etc/shadow, right? These are two different files. So in etc/password, you essentially have, I'll actually cat the ones on my machine. So you have a huge list of basically what are users, right? So I'm gonna like not deal with this output. I'm gonna use the one that they give you. So what they give you is this text, right? And what this is essentially the first thing before the colon is the name of the user account, right? So yeah, /etc. Not, I say etc because that's usually how you read that. It's just etc or etc, doesn't matter, right? So so yeah, that is essentially the user account, right? So if you remember, right, when I tried to netcat, where is this? Yeah, so when I tried to netcat to it, it asked for a username. If it works, yeah, okay, so it asks for a username. From the password file, I already know that the username is going to be root, right? Now I don't know the password, right? So I have to figure the password out, and the password is stored as a hash in the shadow file. And this whole thing is the hash, okay? Now, what is a hash, right? So imagine my password is password, right? Now, if you're going to store this in a file on the system, you can't just store it as plain text like password, right? Because if someone gets access to your computer and they get to read the file that stores the password, they're just gonna see password, like they're gonna see this, right? I'm gonna actually show you what they're gonna see if it's not hashed, right? So they're gonna go, okay, they're gonna see something like this, right? If it wasn't hashed, right? They're just gonna see root, which is the username, password, which is password. These are different things. So this, I believe this is the password expiry date. So it's 9999 just means this doesn't have an expiry date. It's just a bunch of random things. You can read about it on Google if you want. It's not relevant to this. So what we really need to know here is that this is the username and this is a password. If you store it as plain text, like I said, anyone that gets access to your computer will be able to just read this, and they have the password to your account, right? So what is done in Linux, at least, is they hash it, and when they hash it, it turns into this garbage, right? And this cannot actually be reversed, right? So it's not like encryption, right? Like, if you guys have heard about encryption can be decrypted, right? But when you hash stuff, there's no dehash or unhash. You can't do that. You can't go back, right? So the way this works is there's the hash here. Oh, yeah, okay, but there are weak, because Jim just said, or so they think, there are weak hashing algorithms, and if your hashing algorithm is weak, like if you implemented it by yourself, right, and you didn't get it tested by professionals, it might be reversible. You don't know that. So essentially this is not reversible. Just trust me on this. It might be crackable. So that's what I was getting into. So how does Linux know when you type in your password what your correct password is? So let's say, I don't know what this unhashes to, right? So let's say it unhashed to password, right? So if I logged into the account as Faith and I typed in my password as password, the Linux, the OS is gonna take my password, it's gonna hash it manually, right? And then it's going to compare that hash to the hash that is stored, right? And if it matches, then obviously I know the password. But if it doesn't match, then it's just going to say incorrect password, right? So how do we crack it? The easiest way to crack a hash is to, first you have to figure out what sort of hash it is. And the easy way to figure out is, on Linux at least, at the front of the hash, you always have a $sign and a number and another $sign, and that's an identifier for what type of hash it is. In this case, it's $6, right? And if you just go Google $6 what hash, right, it's probably going to tell us it is SHA-512. That's the hash, and it says it's many rounds. That's not the point. Easy hash. Okay, yeah, true. Okay, so yeah, so again, I'll actually go back to do I have a file here? Yeah, okay. So password, for example, that's the text. If I do MD5 sum, do that. MD5 sum password is going to give me a unique hash, right? And this is going to be MD5, right? This is a different type of hash. I can do SHA-512 sum password, and that's a SHA-512 hash, which is what this is, right? So that's what a hash is, right? It's just, it takes the text and it converts it into this, and I cannot possibly reverse this text back into this. It's impossible, right? Unless I know what the original text was, I won't be able to get this back, right? So that's how hashes are used to protect passwords. The way to crack hashes is to use a dictionary, right? So for example, again, assuming my password was password, the dictionary obviously has password right in it. So what you do is you take the dictionary, you start at the top, you go through every single word, and yes, the Oxford Dictionary is good enough. You go through every single word, and you essentially hash every single word until you find one that matches with this hash right here, right? And yes, I'm not talking about the Oxford Dictionary here. There are like huge, like billions of words dictionaries that actually have like past, like passwords that people used to use and passwords that people generally use and stuff like that. So yeah, that's essentially how you crack it. And I think I can just do this online, or I should be able to at least. Cause I can't. You have to run a password cracker. It's gonna take too long. But what does the hint say? Try and try again. If you're not okay, so I have to use RockU. Let me see if I have. So John is a password cracker. I don't have it, so I can install it. Just sudo apt install John. This is a password cracker. So I think it's pretty tiny. Yeah, 7 megs. So just install this real quick, and I'll actually go how to John crack SHA-512 hash. Just do that. Because you know I don't remember all the flags for this. It's a huge amount of things. Oh, I have to do not Vim catch shadow. I have to copy this the password text into a separate file for John. So hash. So I just paste that. Can you just do that? Hash and then word list. Oh, I need RockU. RockU is huge. Fuck. Okay. So RockU is a word list, like I said, it's a dictionary, right? It's 133 megs, right? So it's got a lot of. I'll show you. I'll open it up and you'll see it's. Let's just finish downloading. 45 seconds. So it is essentially okay. It tells you right here. RockU.txt contains 14,341,564 unique passwords used in that many accounts, like previously, right? So yeah. So essentially, what RockU is gonna do, or what John, that this command line like this John tool is gonna do, it's gonna go through RockU. It's gonna take every single password. It's gonna hash it, and then it's gonna compare it with the hash that was given to us until it matches. As soon as it matches, it's gonna tell us, okay, this is the password that hashed to it, and that's how you know that you have the correct password. 30 seconds. Shouldn't take 30 seconds. Should speed up soon. Drink some water real quick. ASMR. I'll turn on my light real quick as well, one sec. Okay. Yeah, drink water, fellas. Stay hydrated and stay safe. And yeah, okay. 15 seconds. I don't know why it keeps slowing down. So I am squatting. I have one of those Bankwest water bottles from last year. So it's fucking lit. They're actually pretty good. Hey. I mean, I like them. Anyway, okay, that's done. I'll mv RockU.txt to here. I'll open RockU so you can see what I mean. It's gonna take a while to load because there's 14 million passwords. Just give it a sec. Okay, so yeah, you see, these are like all the passwords that people use, right? It's just a huge list of passwords that people can possibly or have used before. This isn't even its final form. There's like a bigger one that's like gigabytes or terabytes worth of. I think Jim Ye probably knows the answer to this. I don't know. It's huge, right? But this is a smaller version, right? So anyway, you can do John. Apparently, according to Sam, you can do John hash word list equals RockU.txt. It's starting and it finished. Okay, the password is Hello Kitty, right? It just did it almost instantly. It went through a bunch of. I think it tells you how many it went through per second. It went through 369.2 passwords per second, and it took how long? It took less than a second. So this is probably up there. So that's the password, right? So I can now, if you remember, we were trying to netcat in. So if I netcat in root hello kitty Alright, there we go. Easy. And it tells you John is ripped, so you're supposed to use this tool. And if you didn't know about this tool, you would have to figure it out. So again, if you go to the hint, if at first you don't succeed, try and try again. If you're not careful, these kinds of problems can really rock you. That's a good hint. If you go rock you, Google it, you get word list. And from here you can start to figure out, okay, there's a common password list, so I have to use this somehow to crack it. And yeah. So yeah, so that's how you would figure it out if you didn't know about John. There are other tools you can use. It's not just John. I think Jim Ye mentioned Unshadow, which you just Google it and find a bunch of solutions. And again, I want to reiterate, I'm going through these challenges and you guys are watching, right? That's all good. But you're learning a bit, I hope, from the way I'm doing it. And I would highly suggest you guys go through it yourself at the end as well. Because when you do it yourself, that's where you reinforce what you just learned, and that's when it sticks. So that's what I would suggest you guys do after the stream's over. I don't know. Okay, so that's the password here. Hello Kitty, like that. I hope that is incorrect. What's the thing say? Maybe they can be used to get a password. Oh wait, no, that's not the. Yeah, sorry. Yeah, my bad. Forgot. That's the flag they give you. Alright, John is ripped. Alright, strings. Can you find the flag in this file without actually running it? You can also find the file in the shell server. Okay. Go to the shell server real quick. I'll close these. CD. Paste from browser. Paste. Okay. Yeah, they give you a directory. You just CD to it. ls. Oh, okay. ls. Strings. And if I do file strings, it's probably going to say, what, ASCII text? Oh, it's a set GID elf 64-bit. Okay, if I try to run it, because it did say, again, it says, can you find the flag in this file without actually running it? And we can see it is a elf 64-bit executable, so you can run it. So I'm just gonna run it just to see what happens. Have you ever used the strings function? Check out the man pages. I'm not even gonna bother. The strings function, essentially, why does it keep doing that? It's okay. Strings function and strings. What happens is, it's gonna go through the file and try to find all printable strings, right? All ASCII strings, and give it to me, and I assume the flag is one of them, right? So again, it's a huge list, as you can see. I'm gonna wait for it to hopefully finish. Okay, I'm gonna stop it right there. The Control C doesn't work. Okay, that was a bad idea. I shouldn't have done that. I was gonna try to stop it because we know that the flag format is gonna be PicoCTF and then brackets, whatever, so we can actually use grep again, which we use in the other challenge. We can use grep to. I'm gonna refresh. I can't be bothered waiting for this. Yeah, leave page. So yeah, you can use strings and it's gonna output all of those strings, right? And then you can use lost my train of thought. You can use grep with string to find the flag. So remember, I did strings, right? I'll just do ls again just to show you. So the file is strings right there. So I did strings, and that's gonna output a shit ton of strings. I can pipe it into grep, and if you don't know what the pipe operator does, I'm not gonna go through it. Essentially, it takes all of the text that's going to be outputted by the command on the left, and it's going to send it into grep, and grep is going to search for PicoCTF like that. And as soon as it sees that string, it will probably find the flag. So I'm just going to let it run. Oh, there we go. Okay, strings saves time, right? So instead of outputting all the strings, it only outputs the string that's that we searched for, which is PicoCTF, and that happens to be in one line. So cool, we'll submit it. So yeah, now you learned about the strings command. You can use it to find strings in everything, right? So if I go back to forensics warmup 2, for example, you have flag.jpg, right? If I do strings flag.jpg, you can see there's a bunch of printable strings in the I can't scroll up. Oh, I can. There's a bunch of printable strings in here, right? And it tries to find all of the printable strings and print them out. And I believe one of them is the JFIF that you saw at the beginning of the file, which tells the operating system what type of file it is. Again, just to reiterate, JFIF, JFIF, GIF, GIF, I don't know. Alright, so, yeah. Okay, that's that. Pipe. Oh.
During your adventure, you will likely encounter a situation where you need to process data that you receive over the network rather than through a file. Can you find a way to save the output from this program and search for the flag? Connect with blah blah blah. Okay, so this is again using netcat, right? So we'll go and see that. Okay, that's a that's a lot of output just from connecting to the server. So what is that? It's general skills. So I was just looking at the category on the right. So it's general skills. So I'm gonna go CTF, PicoCTF, make dir p general / what is it called, pipe. So general pipe, just making a directory for the challenge. I'll do nc the thing. Now what you can do with output like that, you can actually send it to a file in the Linux terminal, right? So the way to do this is, again, if I type in this right now, you're gonna see it just outputs a bunch of text. If I instead pipe it using a write, what is the p flag? Okay, I'll explain that. Yeah, so the p flag essentially, I'll actually go back, rmrf general. So what happens is I did make dir p general / pipe like this, right? If I do it without the p, general / pipe is not going to work because it just says cannot create a directory, no such file exists. What p does is it creates general first, and then it goes into general and then create the pipe directory, right? So it's like parent, I believe. If I go man make dir search for that, I don't have to search. It's like here -p, no error if existing, make parent directories as needed, right? So that's just a helpful hint you can use to create like multiple directories within one another. So I'll just do that again. Pretty simple. Pipe. So again, netcat, right? I'll reiterate, it just gives you a bunch of shit, right? You can pipe is not the word. I think it's redirect, right? That's the correct terminology. Sorry. You can redirect the output from whatever the connection gives you into a file. So we just call this file.txt using that right angle bracket, right? So when that happens, it's going to take a while because it's connecting. I believe the connection never closes, right? So it's just going to get stuck. I'm just going to Control C, and we're going to do vim file.txt. Again, there's a bunch of stuff here. In Vim, you can search for PicoCTF like that, and there you go. PicoCTF, almost like Mario. So that's the flag. Again, same deal, right? I didn't spit on my I coughed a little bit. Coronavirus, Monkeyes. Nah, just kidding. No coronavirus here, boys. I've been at home for like the last 2 weeks, so you know. Okay. Inspect me. Web exploitation. Okay, this is web stuff. Getting started. Boys, alright. Fellas, I don't know. Boys is just generic. I don't know. Men, fellas, I don't know. men and ladies in general. I don't know. Alright, yeah, okay, inspect this code. Let's go to the link. So this is web exploitation. So this is, you know, when you hack into a website. It says inspect me. That's pretty self-explanatory. I'm pretty sure all of us have inspected websites before. I learned HTML. Here's part 1 out of 3 of the flag. I'm going to zoom in just to make sure you guys can see it. I learned HTML. Here's part 1 of 3 of the flag. So that's part 1 of 3. Copy this and just paste it here just so we can keep track of it. If that's part 1 of 3, I'm assuming we go into one of the other files to find 2 of 3. Learn JavaScript. Here's part 3 of 3 of the flag. That's empty. Okay, that's part 3 of 3. We want 2 of 3, so that's probably in the other file. So essentially what I'm doing is in HTML, right, you can load other scripts. So it's like, you know, when you do Java and you import stuff, right? It's in the same way when you're doing HTML, you can import other CSS files and JavaScript files. So that would be, this is a CSS file, my css.css. This is a JavaScript file, my js.js. We went into the JavaScript file. It says part 3 of 3 of the flag, which is empty for some reason. So we're just gonna go into my css.css. And yeah, okay, it's down here. Part 2 out of 3 of the flag. Just copy that and place it here. You're for real, Inspector Gadget. All right, cool. That is correct. Again, that was pretty simple, but you know, you learn about HTML and how this works, right? Because you would see this, you might not know what to do next, so you just randomly click stuff until you click here, and then bam, there's the flag, right? So, okay, grep 2. Oh. This one is a little bit harder. Can you find the flag in this, right? Remember, grep is your friend. Okay. Let's go here. Not that either. Here, cd, paste. Okay. I'll clear the screen. Ooh. Okay. ls. Okay, these are all folders. So if I go file 0, ls, there's a bunch of files, right? So you remember with grep before, I did grep search text like this, and then file 0, for example, it's gonna search for it, return 0. Oh no, it does return 0. It just didn't find the text search in that file 0 here. So how do you search in all of these files at the same time? Well, luckily, I'm gonna go back to my terminal because it's easier to read probably. If we go man grep has an option. I'm just gonna search. That didn't work. Where is it? Recursive, right? So grep has an option -r. It says it'll read all files under each directory recursively, and it'll follow symbolic links, blah blah blah. Anyway, it's gonna read every single file recursively from the current directory. So that's what you want to use. And if you didn't know about it, you'd probably have to just Google how to use grep to search for multiple files or anything along those lines, and you would come across this. Unless the hint okay, the hint gives you a grep tutorial, which I assume if you go into, it's probably gonna, if you skim it a little bit, learning regular expression overview, summary. Does this even show you recursive? It doesn't. So this is a very stupid tutorial, unless, yeah, this is a very, I don't know why they link this, because, okay, I don't know why they link this. This doesn't even teach you how to do it. Can't you use, actually, good question. Well, let's try. Grep, Pico, I'm gonna go, wait, am I in the right directory? Oh, okay, so here's what's gonna happen. If you do grep, fucking PicoCTF and star, it's gonna try every single file in the current directory, right? But it won't try every single file in all of those directories, right? So I can technically just go into file 0 and then do that, not find it, cd out, and then go into the next directory and do that and over again until not the 9th directory, right? But instead, you can just do grep-r PicoCTF. It's just gonna go into every single folder for you, search for it, and it's gonna find it. It says it's in files 2/file21. There you go. That's the flag. Grep R. Okay, yeah, grep R, and you will find it. So yeah, that works out. Yeah, solve. Just okay, it didn't copy. That's weird. I don't know why it doesn't work when you copy it like that. You have to Control C and Control V, and there you go. All right. General skills. It's never a bad idea to brush up on those Linux skills or even learn some new ones before you set off on this adventure. Connect with Netcat again, right? So, yeah, connect with Netcat real quick. What do we get? Sweet, we have gotten access into the system, but we aren't root. It's some sort of restricted shell. I can't see what you're typing, but I can. I can't see what you're typing, but I can see your output. I'll be here to help you along the way. If you need help, type echo help me, and I'll see what I can do. There's not much time left, okay? Help me. You got this. Have you looked for any directories? Okay, ls. Passwords secret. cd secret. Now we're cooking. Take a look around and tell me what you find. ls. Sabotage them. Get rid of all their intel files. Alright, so you can do rm intel asterisk to remove all the intel files. Done. Once they're all gone, I think you can drop your file for an exploit. Okay, just type echo drop it in. I place a file in the executables directory, so that is the only place we can execute from. Run the script I wrote to have a little more impact on the system. Executables. Don't look here. Look here. That is a bunch of that's hexadecimal. I can that's okay. Looking through the text above, I think I may have found the password. I'm just having trouble with the username. Oh, Drast, they're onto us. We could get kicked out soon. Quick, print the username to the screen. So we can close the back door and log into what? Is it ID? No. Who am I? Okay. So who am I is the command that prints your username. Okay, I think I've got what we're looking. I'll explain all of this because I don't think they give you enough time. Just to copy the file to the place we can read. CP top secret temp. Oh, CP/temp/top secret into passwords. Quick, go read the file before you. Okay, passwords. What? CD passwords. ls cat top secret. Okay. So I'll go through it, right? We got the flag, but I'll go through it real quick. What happened, right? So, here. We connect to it, right? It tells you, I'll skip the purple text because that's just part of the story. It tells you if you need help, type echo help me, that. So I just type that in. And it said, you got this, have you looked for any directories? So we ls. We look at all of these directories, and by instinct I just went into the secret directory because that's, I don't know, it's just I just picked it, right? And that was correct. Now we are cooking. Take a look around and tell me what you find. Okay, ls, you see a bunch of stuff. Sabotage them, get rid of all their intel files. So what I did was, rm intel asterisk, and the asterisk just means our intel and then anything afterwards, right? So intel followed by anything gets deleted, right? So all of these files get deleted. And nice, once they're all gone, I think I can drop you a file of an exploit, okay? And then you just type echo drop it in, like that, which I did, and then it says it dropped it in. I placed the file in the executables folder, as it looks like that's the only place we can execute from. So just run the script, okay? So I cd back, ls again to see where I am, okay, cd executables, I ls, and that's the file I see. I run it. This is hexadecimal, but it wasn't relevant. I thought we had to like decode it or something, but it wasn't relevant. I think this is just, like in the hacker movies when you run a file or run a hack and it just shows up with a bunch of numbers and letters. That's what they're trying to emulate. But okay, looking through the text, blah blah blah. I found the username. I'm just having trouble with the username. Quick, print the username to the screen so we can close our backdoor and log into the account directly. You have to find another way other than echo. Okay, so I thought ID would work, but ID doesn't work. ID does work actually. If I go to another terminal, I'll show you afterwards. But the other way to print your username is to type in who am I, right? So that prints the username, and after that it says perfect 1 second. Try copying the file from the file called top secret in the temp directory into the passwords folder. So I misread it first, so I tried to copy the file top secret into the temp directory, which is not what it asked for. So then you go cp, so /temp is a temporary directory on Linux. If you turn your machine off, anything in that directory gets deleted. So you copy the file from the temp directory, top secret, into the passwords directory, which was one layer back into passwords. And then you see, oh shit, server's shutting down in 10 seconds. Quick, go read the file. So I tried going directly to passwords, didn't work for some reason, so I had to go back, ls real quick, and then passwords. And then this is a bit stuffed up because of the this bit is a bit stuffed up because of the delay. It's essentially I was typing cat before this showed up, so CAT and then top secret, and this is a story about some commander, I guess, graduating, I don't know, and then you get the flag, right? So that's essentially, that's a bunch of Linux stuff, right? You cd into stuff. When they say the temp directory, you have to remember that the temp directory is in the root directory. So you actually have to go cp /temp/top secret. You can't just go cp temp/top secret. So that's just something you would have to know about Linux. I think there might be a hint about it. Linux for beginners, okay. So they give you, this is a command stuff, but if as a beginner you'd probably see from try copying the file called this in the temp directory, and you would type in just that and it wouldn't work. So you'd go Linux temp directory, right? And you'd figure out there's a /var/temp, but if you read a little bit more, therefore data stored in /var/temp is more persistent than data in /temp. So you would try both, right? And this one works obviously. So yeah, that's how you solve it, I guess. That's how they set it out. It's just Linux stuff. You just learn more about the terminal in a way. Okay, so we got ourselves another web exploitation challenge. What's the time actually? This says 4:03 is incorrect. 7:03. I guess I'll keep running this for another hour and then we'll stop. And then you guys can chill, ask questions. I don't know if we'll figure it out. Okay, so client side is still bad, web exploitation. I forgot my password again, but this time there doesn't seem to be a reset. Can you help me? Okay, go into the link. Welcome to the secure login server. Please enter your credentials to proceed. Well, as a hacker, you try password as the password. Incorrect password. Try admin as the password. Okay. View source to see what's up. Blah blah blah. Standard MD5 implementation. Save the. No, I'm not saving your password. Okay, standard MD5 implementation in md5.js. Again, like I said, you can import, right? In HTML, you can import other files. So this is a JavaScript file. Not found. Okay, I'll go through here. Maybe this works. Not found. That's a bit weird. Okay, right. Okay, that doesn't exist. It's this entire function in JavaScript, right? So essentially they have this function called verify. Check pass equals document.get element by ID pass.value. So for those of you who don't know JavaScript, what this is going to do is whatever password I closed it by mistake. Whatever password I type in here is going to get copied into, I'll zoom in a little bit. It's going to get copied into checkpass, this variable, right? So that's what this is doing. And then it's doing split equals 4. If checkpass.substring split times 7. Okay. So essentially this is the flag, right? Like if you see all of these text, this is the flag, but except it's all garbled up because it's using substring. So what substring does, I'll actually go back to the terminal to explain this. So I'll do vim. So what substring does, right? If you have a string like a b b b b c c c c d d d d, right? If I go substring, let's just make this a variable. Just like this isn't any language, so just do that. If you do substring str as in the variable, and then you do, let's say 0 to 4, right? This is just an example implementation, right? What this is gonna do is it's gonna go through the string. It's gonna go from the 0th position, inclusive on the lower side, so 0 inclusive, 0, 1, 2, 3, 4, right? But it's not gonna include 4. It's just gonna go 0 to 3, right? It includes the lower bound, but not the upper bound. So it's gonna this essentially is this same as AAA, essentially. This stream is not being saved. I did not. Yeah, I can set that up for next time. I didn't think of setting it up, so that's my bad. But okay. So yeah, essentially that's what substring is doing. Again, if I did 4 to 8, it would be the same as BBBB or BBBB, yeah. So that's what substring is doing. And if we go back here, split is set to 4. Check pass.substring, so this is a little bit of a different substring. You don't have to pass in the string as the first argument. You just call substring on check pass, and it just does split times 7, comma split times 8. So it's just that variable, and it does all of this, and it essentially that's, you can see it's just the flag, right? And what I'm gonna assume here is that this is the flag backwards, because it goes 7 to 8, 6 to 7, 5 to 6, 4 to 5. If you notice, it's just going down from 7, 6, 5, 4, 3, 2, 0 to nothing, and 8, 7, 6, 5, 4, 3, 2, right? So what I'm gonna assume is if I'll use the URL place as a placeholder. If I start typing in PicoCTF, that's not gonna work, is it? I'll just make this smaller. So what I'm going to assume is I don't actually have to write any code. I can just go backwards. So starting at PicoCTF client, blah blah blah, and that's just going to work, right? So you go PicoCTF. So I'm just going back or like up. So just in case anyone's still confused, is bad 5E06AC. That's the flag, right? So it's just backwards. That's what I'm assuming based on all the numbers here. And you just copy all of that. I'll full screen this. Go back. Hopefully this is the flag. Okay, that's correct, right? So that was pretty simple, but yeah, that's essentially that. So yeah, and I assume if I go here and use that flag, copy paste it as a password, you got the flag, right? So that's the code. That's how it works, right? So yeah. So that was just some reverse engineering, sort of. You know, you look at the code, you try to make sense of what it's doing. You can go the long route. Instead of trying to understand the code, you just try to write a script that reverses it directly. But you know, it's just, yeah, this is pretty self-explanatory, I guess. Right? So yeah. Yeah. Okay. So next challenge is forensics. Oh. You can, okay, yeah, I think Twitch might save videos like the last 10 by default. I don't know. Hopefully it does. If it does, then that's good. I didn't set anything up for it specifically. So if Twitch doesn't do it, I know YouTube does for a fact, so I'll just stream on YouTube next week if we do this again. Hopefully people are liking it and want to see it again. I don't know. Okay. So yeah, this is essentially, you know, how hacking works, sort of. You just set it? Okay. Alright. Well, I didn't set it, so I'll set it next time around. Okay, so Desroulé. I think that's how you pronounce it, I'm not French. Our network administrator is having some trouble handling the tickets for all of our incidents. Can you help him out by answering all of the questions? Connect with that, and they give you a file. I'll just download the file real quick. Save. Close this. So, what is it called again? Des Roulet. Okay, I'll make directory in general des Roulet. Whatever. Okay. Okay, so that's the netcat that they give you to connect to a server and a port. So you go here. You'll need to consult the file incidents.json to answer the following questions. What is the most common source IP? Okay, so I'm gonna use get-it because I can just like leave it on the side, sort of. Incidents.json. Okay. I would use Vim because I'm a Vim fan, but this is just, I have to open another terminal, I can't be bothered. Okay, so what is the most common source IP address? If there's more than one IP address that is the most common, you may give any of the most common ones. Okay, so source IP, that is the same as that. I can see that comes 3-4 times. I'm just gonna assume it's this one because I just saw it 4 times, just as an assumption. I can grep it. Yes, I can grep it, but you know, well, why grep it? It's pretty easy. How many unique destination IP addresses were targeted by the source IP address? I'm just gonna manually do it. That's 1, that's 2, that's 3, that's 4, that's 5. I saw that just then, right? No, I didn't. That's 6. I saw this for sure. Yeah, okay, so that's 6. 6 still 6. Okay, that's 6. That's okay. So it's 7. Alright, the answer is 7. Now we know. 186.120.220.162 7. Okay. What? Okay. Alright. I'm gonna probably have to script this. Unless I'm doing something wrong. Or it's 5. I'm just gonna I can't be bothered. I'll just do it just trial and error, because you know it's kind of stupid. It's either 5, 6, or 7. Okay. We'll just count this again one more time, real quick. That's 1, 2, 3, 4, 5, 6. I just saw this, right? Yeah, that's still 6. That's still 6. I just saw this up there. That's the same as this, so the answer is 6, except unless I read the question wrong. How many unique destination IP addresses were targeted by the... Okay, that's my bad. I didn't read the whole thing. That's kind of stupid. All right, so okay, what's the source IP? It is 40.91. I'll copy this and search for it. I didn't copy it. Okay. There. So that's source IP 1. Oh, okay. Oh, what the fuck just happened? Oh, it's just, okay, so it's just 1. The answer is just 1, because that's the only source IP in this list. So, okay, we'll connect again. 186.120.220.162. It's just 1. Yeah, that's kind of... Are you kidding me? Oh, they give you a different IP each time. Okay, that makes more sense. Now it makes more sense. All right. 186.120.220.162. Again, this is the sort of things you run into in CTFs, right? So, all right, just search. It says 1 of 4, therefore there's 4, right? Like it says, if I'll show it again, it says on the top, it says there's 1 of 4 source IPs. Actually, no, it says unique, right? So I actually do have to look at it. So there's 1 unique, 2 unique, 3 unique. Ooh, no, it is 3 unique because the first one and the last one have the same destination IPs, so that should be correct. Yep, okay, what is the number of unique destination IPs a file is sent on average? What? Number of unique destination IPs a file is sent on average needs to be correct 2 decimal places. Huh? What? Okay. Okay. So these are all separate files. I have to look at... Wait, these are all... Wait, are there unique files? Okay, you know what? No, it's not, because that's the same as that I just saw, right? Wait. I'm gonna just skip this because this is annoying, right? I can't, you know, this is not fun to watch. I know for a fact this is not fun to watch. So, technically this is a part of hacking, right? So if you do like incident response or I believe for like forensics analysis, you would have to go through, not manually, you would probably write a script for it, can't be bothered doing it. So also I'll just rm the incidents.json file I downloaded for the challenge, didn't use it. I'll just skip it, right? Because you can do a script and figure it out, but I can't be bothered. What does the hint say? If you need to code, yeah, but it says you should probably script it up. Python has a JSON library that's easy to do, like work with. Can't be bothered, right? So skip that because it's boring. Log on, right? I made a website, so now you can log on to, okay. I don't seem to have the admin password. See if you can't get to the flag. Okay. Go to the website. Alright, look, I'm not a defense guy. The incident response / forensic stuff is for like defensive security, right? I'm not into that, so it is sort of boring for me, and it is boring to watch me go through a freaking JSON file trying to figure out, ooh, how many destination IPs are unique to this file, and you know, it's can't be bothered, right? Alright, so you have a my new website. I'll just go admin. Don't save. Sorry, the admin account password is super secure. You're not getting in that way. Alright. I already have a feeling I know how to solve this. I'll just go page source anyway. Categories, blah blah blah. Okay, there's nothing weird here, right, that I can see, because you know it's just like it's loading scripts, right? But these are from other websites, so they're out of scope, right? They're not gonna be on this. They're not gonna be in scope. There's a log out thing, but that's the button here. Okay, so yeah, there's nothing in the view source, right? So what I'm gonna do is I'm gonna just enter a single quote for both the username and the password and see what happens. Okay, you logged in, not sure you're able to see the flag, no flag for you. Okay, so I assume what they want you to do is just try to put in random characters. So if I just go like a semicolon, what happens? Yeah, so they just want you to sort of get into that mindset where when you don't know what to do, you just try random shit, right? That's what they want you to do. And if you just try random thing for username and password, they tell you logged in, but you can't see the flag. So what I assume you have to do is, if it signs out, still loading, you have to go admin and then a symbol, any symbol. Okay. What about admin and a thingy? Oh, didn't want to click that. And then any symbol, right? So admin something symbol. Okay. Well, let's view source of this page. You don't see anything specifically. Okay. I'll just try something. Let's see if that. Okay, it doesn't. You're not getting in that way. Okay, the next thing I would try probably is to look for cookies, right? So I'll log in as someone, right? So ASD and then a symbol, right? Alright, so the next thing I would look for is cookies, right? So if you guys don't know what a cookie is, I'm pretty sure most of you guys probably heard about it. So if I go F12 and storage, right? Yeah, okay, cookies, right? I can't zoom in on this. Okay, I can. Wow, cool. So cookies are what you use to keep track of sessions, right? So say, for example, you log into YouTube or Facebook, right? And then you close the website. And then when you go back, they keep you logged in, right? And the way they do it is through cookies, right? So when I just logged in as the user ASD, you can see it right here, right? There's a thing right here, username ASD, password that. So what I'm assuming I can do is I can just change the username to admin. I believe the password won't matter, so I'll just refresh. It didn't. Can I do Shift F5? No. Control. Okay, that's not. Wait. Okay, that didn't do it. So setting it to admin does. Okay, there's another. Okay, yeah, it's right here. There's another thing called admin, and it's set to false. I'll just set it to true, and then refresh. Hopefully. Okay, there you go. Right. So again, this is a form of a very weak. This is a very weak example of a cookie, right? Usually if you go on Facebook and you try to look at your cookie, it's not going to be that easy. It's not just going to be, oh, admin equals false, right? But that's the sort of thing that they want you to learn with this challenge, right? You just keep on trying until you figure out, okay, cookies is what I need to be looking at, right? And then you just change admin to true, and there you go. That was sort of confusing. I might have gone too fast. Does anyone want me to explain that again? Just say yes or no in chat. No, not that one. Yes, Spec is right with what he said. So stateful information, so stateful in this case means something that can change depending on what you do. I can explain this again, like from the start. So that's one yes, that's two. Okay, I'll explain this again, right? I'll sign out. So again, I don't actually think it matters what symbol you use. I can just go like ASD, and it's probably gonna log in. Yeah, okay, so it does log in, right? It doesn't matter what you type in. Only when you type in admin as the username and you type anything in as the password, it tells you, I'm sorry, the admin password is super secure. You're not getting in that way, right? So, okay. So what I was getting at again, cookies are used by So I think I can actually use PicoCTF as an example, right? Because I'm logged in here. That's my username up there. So if I go F12, storage, you can see there's a cookie right here, right? And you can see there's, I can zoom in, right? Yeah, okay. So, wow, this is, yeah, okay, that's better. So when you come into storage, I'm on Firefox, right? Chrome might be a little different. So when you come into, you press F12 to open up this menu and you go into storage, you see for PicoCTF, they have a very good cookie implementation going on. Because, can I extend? I can't extend that. Okay, so essentially what they have is a token, right? And this is a randomized token. I'll copy and paste this up here. You see this, you can actually try to type it in here, but it's not gonna work because they also have a Flask thing right here, which I'm not gonna show. I don't know if both of them together let you in to my account, or I can just log out and fix it. But essentially, this is what they use, and this is randomized every time I log in. So this is not brute forceable, right? You can't just log into your own account and then just randomly change yours to a random string and get into someone else's account. That won't work. But for a weak website like this, right? If I log in as, say, Faith and password Faith, and it lets you log in, right? It just tells you you're logged in. If I go F12, zoom in again, bring this up, you can see this is a very weak implementation of a cookie because it stores the username, the password, and something called admin that's set to false, which is suspicious, right? It just sets that as a cookie, right? So, well, first thing I would think of, I didn't see this first, so I tried changing the username to admin. But then if you think about it, if there's an admin thing that's set to false, you can just try setting it to true, right? Because that's what's used to determine, or you can assume that's what's being used to determine whether you're an admin or not, right? Because if it's false, you're not admin, obviously, because you can't see the flag. But if you set it to true, and then you hit refresh, all of a sudden you become admin, right? That's how the cookie sort of works. That's the cookie system, right? And you can read more about it on, how are cookies used in websites, for example. You can just Google that. Cookies are mostly used to track website activity when you visit the sites, blah, 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 right? You can read more about cookies if you want, now that you know how that works, right? So, yeah, that's essentially how I knew about cookies from beforehand. If you were just starting out, you would probably get stuck, and I assume there's a hint. I'll actually check. There should be a hint on this. It doesn't seem to check anyone's password except for admins. How does it check the admin's password? So you would have to use these hints to how does a website check you? But that's not gonna work, right? That's probably not gonna come up with anything. Oh, it does actually. How do modern websites check your password without actually storing it? And hashing, exploit collisions. I'm just trying to see how you guys could have figured it out without knowing about cookies. Just to see what you guys would have probably had to Google. None of that. You would probably have to Google how does a website store login information? That's a very vaguely worded question. How do I store passwords and usernames? Here, okay, there's one right here. Store your login in both the password manager and cookies. A cookie is a piece of information that a website stores, right? So again, when you get stuck, yeah, assuming you don't know about cookies, that's what I mean. That's why I'm trying to, get in your shoes, right? Assuming you didn't know about cookies. How do you go from a random a login to figuring out about cookies? You sort of just Google, right? You sort of Google until you come across, you read everything, right? That's another part of being a offensive hacker or offensive security person. You have to read everything you come across, right? So I would probably click every single one of these links and read everything and find what's relevant. And I'd come across this link down here, and I'd read all of this as well. And you go to cookies, and it says an advantage of using cookies is they can keep you logged in a website so that you can skip the login page and quickly get to where you want. And when you hear about this, you go back to the website, or you can actually go Firefox, how to check my cookies, for example, right? And here it says press F12 to open Firefox developer tools, go to storage tab, expand cookies node, and essentially that's here, right? So F12 storage tab, cookies, right? So that's how you would figure it out. Again, what I want to reiterate is when you do your research to try to solve CTF challenges, you will get stuck. You won't know what to do. The important thing is to keep looking, right? Keep trying to, no matter, you're gonna waste time in the beginning trying to find the right resource, but you know, even if you don't find the right resource right away, like if you didn't find this right away, and if you didn't then immediately go Google Firefox how to check my cookies, just assuming, right? You're still gonna go through and go back one more. Well, that's weird. Okay, yeah. So you're still gonna go through all of these links, like how do websites store passwords and usernames, for example, and you're just gonna read all of this, and it's just like, it might not be relevant to the challenge, but you're still gonna read it, right? And you're gonna like learn new things, and that's all that matters, right? You're just here to learn, right? Solving the challenge is secondary to learning, right? That's all I want to reiterate. Okay, so moving on from that, yeah, so we just solved that. Hopefully that makes sense. The challenge is called log on. If you're listening, I'll type it in. Okay, yeah, so I hope that made sense. You can sort of type in chat if that didn't make sense. I don't know how else to explain it. Like, if that didn't make sense, you probably should go into PicoCTF and, you know, just go through it yourself to explain it more to yourself and reinforce the knowledge. But yeah, okay. So I'll move on from there. Forensics. Reading between the eyes. Stegosaurus hid a message for you in this image. Can you retrieve it? What's with them misspelling retrieve? Okay. This image. I'm not gonna click the hints just yet. I'll download the image. It's forensics, reading between the eyes. So I'll go back to forensics, make your read between. I don't want a long ass folder name, so MV download. Oh, I didn't finish downloading? Oh, okay. Wow, that's a large image. I was gonna say it wasn't letting me copy or move it, so just wait for that real quick. Damn, internet's slow. The hell? Okay. Oh, it opened it automatically. Okay, so this is the image. I'll actually move it to the folder. Oh, I think I clicked open with. That's why that didn't work. I'll save. Yeah, I'll open the image again so you guys can see the cute dog. I didn't do Desroulet, no. Oh, he's not in the. Okay. I'll type it in. Oh, you're watching? I don't know if you're watching. Okay, cool. Yeah, I skipped it because it was just like a huge JSON file. Or not huge, it's just annoying, tedious. So, okay, Husky. So I'll move that to the current folder, and then I'll go to File Manager, go Forensics, read between the eyes. So this is a Husky, right? And now it's, remember what the challenge said, right? It's a bit confusing. Stegosaurus hid a message for you in this image. Can you retrieve it, right? And this is, remember, this is forensics, right? So just looking at the image is probably not gonna do it. Like, you can try zooming in. If I zoom in, but that says top paw down here, so that's not the flag. It's definitely not the flag. So you know, you can try looking at the image all you want, but remember, this is forensics, right? So you want to do whatever it takes to figure out, because remember, again, if I open husky.png in Vim, right, you can see there's a bunch of text, right? And remember, it doesn't stop anyone, or no one's like, no one's like limited to not storing the flag in like this, all of this text here somewhere, right? You can grep it, yeah, but grep on this, I don't know, we'll try PicoCTF Husky. Grep might not work, but remember, there's also strings, right? So that's what I was trying to get at. If you strings on the image, it's gonna try to find all printable strings in the image and show it to you, right? So we'll try that. That's a lot of things, but remember, we can pipe it into grep and search for PicoCTF. That didn't work either. Okay, so now you would be stuck, right? You wouldn't, because this is what you learned from the previous challenges. You'd be like, what the hell do I do? Okay, and you would have probably already looked at the hints. I didn't, so I'll look at the hints. I know what to do, but I'm just trying to go with you guys. Maybe you can find an online decoder. Okay, that's not really that helpful. We can just go online image decoder. Let's see what that says. Oh, okay, steganography online, right? So you see steganography, probably don't know what it means. Steganography definition. Steganography, the practice of concealing messages or information within other non-secret text or data. Cool, okay. Steganography online, let's try to use this, right? That's what the hint said. Encode message we want to decode, right? Decode image. browse. Okay, let's browse. Where is it? CTFs, PicoCTF 2018, forensics. This, and that's the image. Open. Okay, then let's decode. Hopefully this works. Yeah, okay. So what I was more thinking of was there are command line tools that let you do what this just did through the terminal, right? Why won't this let me click on? What the hell? Okay. I don't know, this is acting kind of weird. But essentially, yeah, so you can hide text within images that is not visible to like strings or grep or etc. So this is something weird's going on. Like I don't know what's going on. I'm just gonna copy this real quick. I don't know, because when I keep clicking, it's just like doing that. I don't know. Okay. Yeah, I got hacked, dude. Yeah, so reading between the, is that the flag? That's not the correct flag. I think you have to, yeah, okay. So that is I'm gonna close that. Okay. I'm gonna close all of this as well, because we opened all of this before. So it says reading between, the flag is a little stuffed up here. So I assume we have to like manually fix this, because it is forensics, remember. So PicoCTF reading between the something. So between the bytes, what is this? I'll just take this. Reading between, I'll just do that, like move that to the end. That is incorrect. Reading between these, I'll take the 3 and move it here. Oh no, that's not it. Wait, I'm gonna go back to what the flag was. Reading between, bro, what the hell is going on my Twitch chat? What the fuck? What the hell? I'm just looking at the Twitch chat. What the hell is going on? I wasn't looking at Twitch chat at all, actually. So, anyway, so okay, cool. It's a bot. Can I ban it? I don't know. Yeah, I wasn't actually looking at Twitch chat at all. Oh, I can ban user. Okay, I'll just ban. All right, cool. Okay. Yeah, okay. Let me know if anything weird goes on in Twitch chat, because I have Discord open. I'm not actually looking at Twitch chat. So if you guys post stuff there, I'm not like, you can troll there all you want. Just yeah, I'm not actually looking there. Anyway, so we have to figure this out. What the hell is this? Okay, I'll type all of this in backwards. 37YB_3. Just trying to figure out what the hell this is. Reading between. What? Reading between. What is this? Maybe you can find an online decoder. Okay, I don't know if this is a problem with the decoder, because I can't. This is not guessable, right? Yeah, I'll just try something else. That's what I was gonna say. So steganography image decoder. Let's just look for something. It's not. I can't decode again. Okay. Steganographic decoder. Well, we'll see. We'll just use this. Oh, it says it has to be a JPEG. I think I have a PNG. Right. I have a PNG. I don't think that's gonna work, because it says select a JPEG, WAV, or AU file. It's probably not gonna work. If it doesn't work, I'll just go use another one. Okay. While that loads, I'll just go back. I'll use another one. That's just still loading. Unhide image. CTFs, speaker, crypto, not crypto. Oops. Forensics, reading between the eyes, husky.png. What the hell is this? That doesn't work. This file may not, yeah, that's not gonna work. Okay, well, I am looking like well, I'm not a forensics guy, like I said, I'm offensive security, not defensive, so, that's looking, yeah, okay, yeah, I know, it's looking for, yeah, it's doing that, alright, gonna skip that. Hide message or decode this image instead, yeah, sure. I'll try this. I'm just going through all the possible thingies. Otherwise, if this doesn't work as well, I'm just gonna go for the command line tool I was talking about. See if this works. Still okay. Uploaded file too big. Nice. Honestly, I can't be bothered. Like, I'll just see steg hide. Can you do sudo apt install? I can. Okay, apt install steg. So steg hide is one of the tools that might work. I don't know. I'll download it and try. Yeah, steg hide is just steganography hide, so you can just use it to unhide stuff, and it gets text and not images. So steg hide husky. Ooh, steg hide help. Let's see what it says. Extract. Well, I'll try this one. Steg hide extract husky. Okay, what's the fucking syntax? Does it say at the bottom? Okay, so here, steg hide extract SF. Okay, we'll try that. Steg. Oh, I'll clean it, or I'll steg hide again just so you guys can see. So it says, you know, steg hide extract SF husky. Enter passphrase. I'm assuming there's no password. File format is not. Okay. Well, that's not gonna work. There's a one for PNG as well. What is it called? It's called Ruby Steganography Tool. I forgot what it's called, but it's in Ruby. Hopefully I can find it real quick. Not steg hide, not foremost, not steg solve, not none of that. zsteg, that's the one. So okay, is that installed? That's not installed. Install zsteg. This is another one for PNG specifically, because you can see that obviously only works with JPEGs for some reason, unless there's a way to specify. Wait, there might be a way to specify. Steg hide on PNG files. Let's see. Steganography 101. I don't want that. I'm just skimming through. Like, you should probably read all of this, but I've read this before. I'm just trying to see if there's a way to get PNG stuff. It doesn't look like it from here. I'll just install zsteg. Gem install. Do I have gem? Oh, gem. Okay, I'm not installing Ruby. It's gonna take too long. Okay, honestly, I'm gonna skip it because it's gonna take too long to install the tool that I was gonna use. That's probably gonna work. Yeah. So you have the flag. It's just I don't know why it's. I'll actually try to decode it again, like someone did suggest. So hopefully it works the second. Not this one. Sorry. Decode. Hopefully it works second time around. Second time's the charm, maybe. Cute husky. I can't zoom out. Oh, I can't zoom out. Okay. Ooh, okay, no, it does work. What the fuck? Oh, okay. It's laggy. I'm not actually doing that. It's a little very laggy. Okay, I'm just gonna read it. 7H3 BY73S. Okay, just do that. 7H3 BY73S. Okay. Cool, we did it somehow. Yeah, true. You're right. I should have just decoded it again from the start. What am I doing? All right. So, oh, okay. Do people want to see more forensic stuff, or do you want me to go more into the reversing, binary exploitation, crypto stuff? Because there's like 2 more forensics challenges. I can skip it if you guys want. Like, type it in on the Discord chat, not the Twitch chat. Binary. Alright, skip forensics. Cool. Yeah, no one likes forensics. Where's Ben? Yeah, Ben left. Yeah, the guy named Pix on the Discord, he loves forensics. Don't tell him I said this, but forensics is kind of boring. I could go tell him I said this, it doesn't matter. Alright, cool. So, reversing. Alright. It says assembly-0. What does ASM0 hex D8 hex 7A return? Submit the flag as a hexadecimal value starting with 0x. Note, your submission for this question will not be in the normal flag format. Source located in the directory at here. Okay, we'll just go to the directory because I'm not downloading that. Ooh, okay. So, this is going to be interesting. You're going to learn something really good, right? Okay. Who here has heard about assembly? Let me get a show of yes. Yes, just no need to type no, just like yes. Let me see how many people here might have heard about assembly before. Alright. Okay, that's 4 out of however many we have in this chat. So okay, alright, that's okay, that's a good number. So yeah, so I'll still explain it anyway, just because, you know, we're in the wrong directory. What the hell happened here? I might not have copied it correctly, so I'm still gonna go through it anyway, just to, you know, just in case, because, you know, sometimes it happens a lot with me. Sometimes you think you know something, but then you don't. I'll just go through it anyway. So you have a file called intro_asm_rev.s. So I'm just gonna go. I hope they have Vim. They should. Okay, cool. that is terrible. I'm gonna not do that. I'm gonna actually download it. That syntax is horrible. We'll go cd dot make dir reversing dash p reversing slash what is it called? ASM0 whatever. Okay, mv download that to here, move it here, and then vim. Okay, cool, that's much better. I'm gonna actually do that so it's more centered. And I'll also okay, cool. It's just centering it out a little bit. Okay. So what is assembly? Right? That's the big question. So this is assembly. This is a language that where do I start? So when you write your C programs, right? When you compile your C programs, they actually get compiled directly to machine code, right? And machine code, as you might know, is just like ones and zeros, right? Literally, that's what machine code is, because a computer only understands zeros and ones, right? It's either on or not. What assembly is like a middle language between C and machine code, and it is very low level. It is very what's the word? It's very well, what's the word I'm looking for? It's like very descriptive, or not even descriptive. It's very verbose. Okay, verbose is probably the word. So, for example, when it says push EBP, okay, this is not gonna, I'm gonna first look at what I exactly wanted. ASM0, hex D8, hex 7A. Okay, so wow, I'm gonna look at the hint for how they explain it. Basic assembly tutorial, assembly registers, because it is memory, yes. I just don't know what the best way to explain it is, so I'm gonna go through how they do it. Data section, blah blah blah. Okay, they explain hello world in assembly. Okay, registers. Let's start with registers. Right. Okay. So in assembly, I'm gonna actually Google how many registers. 32-bit x86 number of registers, because I don't know this off the top of my head. There's 8 registers. Okay, so you see how it says push EBP, move EBP ESP, move EAX. Ignore this for now. Okay, move EBX, EAX, EB. Okay, so essentially in assembly you don't have variables, right? Like in C, for example, you would have, you know, int. I'm actually gonna mute my Discord mic. I hope Benno, are you listening on Discord? Or I hope you're not. I hope you guys probably muted me already, but I'm gonna mute it anyway, just in case. Okay, so yeah. What was I saying? Okay, so in assembly, right? If you compare it to C, in C, if you want a variable, right, you want to store, say, the number 5 in a variable, you just go int a equals 0, right? And that's that. However, in assembly, you don't actually have variables like this. What you do have are 8 registers, 3 of which have special meaning, so you can't use them. So essentially, 8 minus 3, you have 5 registers, and registers are like variables, right? In this case, the registers are, I'm gonna list them out with new lines, or not new lines, I'm gonna list out the reserved ones, the special ones, and the other ones are EDI, ESI, EDX, EBX, ECX, that's 5, okay, yeah, that's 8, like, that's all the registers, right? Off the top of my head, that's the 8 registers that you have in 32-bit machines. So this is all, because now you're in modern machines are 64-bit, right? But this is 32-bit. Just these are all 32-bit registers. And what 32-bit versus 64-bit means is, actually, I'll just go to calculator real quick. Is there a calculator here? Yeah. Okay. So what 32-bit versus 64-bit really means, if the calculator starts up, what the hell is this? Here. So I'll go advanced mode. Okay. So in 32-bit registers, the max value, or the maximum, the highest number that you can store is 2 to the power 32 minus 1, right? So that's that value, right? In 64-bit registers, which is your modern machines, a register can actually store 2 to the power 64 take 1, which is, as you can see, a much larger number. That sort of, that sort of explains why modern computers are much faster than the ones from previous times, right? Why do you take minus 1? Because actually, why do you take minus 1? There is a reason for it. It doesn't matter in this context, right? The minus, it doesn't, no, actually, it's not minus 1. It is 2 to the 64 and 2 to the 32. When it starts from 0, it starts from 0, that matters as well, but the -1 also matters when you have signed numbers, right? Because you have negative numbers and positive numbers. So then you would, I'm not gonna go into that, okay? Just okay, yeah. So it starts at 0. Thanks, accurate. Thanks for explaining. I had a brain freeze right there. So that's why you take -1 away, because you start at 0 and you go up, right? Okay. Yeah. So these are the 8 registers. That's the difference between 32-bit and 64-bit, right? So what this is doing, who here remembers from UCP, or you guys are learning UCP? There's a couple people here that are doing UCP right now, I think, or at least one person here is doing UCP right now. So who here knows about like the stack, right, where your function stack frames are? Let me get like a show of hands, just to make sure how deep I need to go into it. I don't know if they've covered functions and like stacks yet in UCP. So if they haven't, I do have to cover it. And you're gonna learn this in like 2 weeks, probably 2 or 3 weeks. It does go over stacks a little bit, which is enough to get started here. A bit. Is the music too bad, or what do you mean that music? Okay, you think you're too advanced? Wait, hold on. Let me look at the when you get to the next challenge, I'll try my best to explain it, right? And you know, that's gonna take a while, okay? I'm just trying to explain this for everyone here that doesn't know any assembly. Okay. Alright, music is cool, alright. Yeah, so again, so you're in UCP currently. Okay, I'm just gonna explain what stacks are. So in C, right? When you have functions, right? Let's see, I'm gonna actually Google stacks in C. Okay, cool. Oh, we'll use, okay, wait, C, ELF, runtime memory layout. Let's just do this, right? Might be easier. Okay, not that. I need a nice, none of those. Sorry, give me a sec. Let me just find the right screenshot. Yeah, this one probably works. If I can view image, where is it? Not view image info, view image. That's unreadable. Hold up. Give me a sec. I'll find a good image for you guys so that I can explain it. All of this is like upside down because you want to look at stacks from like stack is at the bottom, which is what I go through. Okay. I'm just gonna open up Paint real quick. Not here. Sorry. Paint. Oh, this is the best way to explain it, right? Okay. So we have. I'll turn up the size. So that's too thick. Okay. So let's say you have. Yes, I was in a VM this whole time. So let's say you start your C program, right? Now your C program has its memory, right? And when I say memory, like when you like store stuff in variables and whatnot, right? The C program, when you start it up, lays its memory out in a specific way, right? So at the very top, say here, is your text segment, right? I'm gonna. Okay, okay, that's a text segment, right? And in the text segment, what you have is all of your code written in machine code, right? So this is like the code in your program, right? So if you have like a hello world program, when you compile it, this section would have the hello world program in machine code in this segment at the top, right? And again, okay, actually I actually wanna say something here as well. Where is this? So this part, whoops. Oh, what the hell? Okay, this is memory address, say 0, right? I'll use hex because that's how you deal with memory addresses. So this is memory address 0, and wow, this is hard. It's actually not as easy as I anticipated it to be. And this is memory address like let's say, I don't know, hex FFFF, okay? Just a high, like a large number, right? So what I want to again say is that from top to bottom, it goes from 0 to hex, whatever, like a large number, right? It increases top to bottom, right? So the text segment is lower in the memory space of your program. And so you have the memory space of your code, right? and sorry, but this is where the machine code for your program lives. After this is where you have the data segment, right? So I'll just, where is it? Data, or data segment. And in the data segment is where all your global variables, and that's it. It's always in here is all your global variables, right? So if if you're doing PDI or UCP, you know not to use global variables. But if you do end up using global variables, this is where they get stored, right? And after this, there are a bunch of other things, miscellaneous stuff that you don't need to know about, like shared libraries. You can do your research into it if you want to learn about it. So I'm going to skip this. It doesn't matter what's here. After this here, you have your heap, right? And in UCP, you can use malloc. I assume they've taught you about malloc by now. So when you use malloc and you allocate space for a variable on the heap, this is where that variable goes, right? And finally, I'll actually put a line here and say that the heap grows downwards. This is a term, I'll explain what I mean. Second from the right, that's Streamlabs OBS. That's what I'm using to stream. And this is the stack, which is the final thing that I wanted to get into. This is the most important part of it. Can I use a pencil? It's much easier probably. Okay, whatever, that works. Okay, so the heap is where your malloc variables are stored, and the stack is where your local variables are stored. So now what's the difference between a local and a global variable? Well, a local variable is a variable that's inside a function, right? So, a local variable, like, you have int main void, right? Or int main int RGC char RGV. RGC and RGV would be stored here, right? And then you might have, int a is equal to 0, printf %d a, blah, blah, blah. The variable a is stored in the stack, right? And what happens is, whenever you call a function, right, stuff for the function gets pushed onto the stack, right? So the stack keeps growing up, and it keeps growing up until there's a maximum limit for it. It can't just grow all the way like up here. That's not allowed. It can't hit any other memory region. So there's a limit, and if you hit that, you get like a stack out of memory error, something. And it's the same for the heap. If you keep mallocing over and over again, the heap will need to grow. So the heap grows downwards, and etc. Right? So why am I explaining this? If I go back to my VM and go back to here, when it says push EBP, push instructions always push on top of the stack, right? So when I do a push, the stack grows upwards a little bit, and whatever I just pushed gets put on the top, right? So that's what you need to know. Move instructions. So okay, here you have 4 instructions. So the instructions are the first word, right? So the first word on the left here. So push, move, pop, and read. These are the 4 instructions you have in this sort of assembly, right? So I'm only going to explain these 4 instructions, and I'll explain. So the push, like I said, just pushes whatever value is in that EBP register, which is a reserved register. I don't know if I'll have to explain it, so I'll get into it in a little bit if I do need to explain what that register is used for. I'll actually put a message here. So these are reserved, and these are user defined. I don't know what the term is. I'll just do that. Okay, so I'll explain what this is used for if I need to in a sec. So what move does, the syntax for the move instruction is move destination source, right? So what move is doing here is it's taking the value out of the source register, so ESP, and moving it into EBP, the base, the other register, right? Okay. So it does this, then it goes move dword pointer. Dword stands for double word, pointer stands for pointer. EBP plus hex 8 into EAX, right? So again, this is source, destination, right? Same, it's that same concept from the instruction. Now this is where it gets very confusing, right? So I'm going to go through their tutorial just to figure out where they teach you what that means, so I can show you how you can figure it out. It probably doesn't show it to you here. It's probably here. Let's go argument function stack. Not what I want. Why do they give you tutorials like this that don't explain what you need to know for EBP plus? No, okay. Argument. Okay, this is okay. Wait. They have a huge list. Okay, this is a huge tutorial, right? So you probably would have to go through and learn a bunch of stuff, right? I'll find what I was trying to explain. It's probably procedures. It's not procedures. System calls, registers. Trying to find exactly what I need to. Variables might have it. EBP plus. Function calls is what I need. Constants, system calls, not system calls. Unless, no, it's not. Sorry, just give me a moment. I'm just trying to find out how you guys can learn it without me being here, right? If you were trying to do this challenge yourself. None of these here. Assembly tutorial. Let me just, because you know they give you an assembly tutorial, but it's not good enough. Is that tutorial point? It is. I shouldn't have clicked that. Actually, okay. Let's just do this, right? The simple way, the lazy way. You don't know what this means. Copy and paste this into Google. See what happens. What does this assembly language program output? All right, cool. Okay, this is the PicoCTF. This is the challenge. So you can read this if you want. This gives you the answer to the challenge, and I'm assuming there's a very good answer for it as well. Some guy goes into explaining the whole thing. I'm not gonna read that. Okay. I'm just gonna explain it my way, right? If I were to explain it to you without you trying to figure it out, because if you can figure it out by doing that, right? For example, you go through it, it's not actually cheating if you look at this answer, so long as you actually read everything here and understand exactly what's going on before you move on, right? Never actually skip a challenge just because you don't understand it, right? That's never what you want to do. You always want to understand exactly what's going on before you move on, right? This guy does probably explain it pretty well. I'm gonna not do that. I'm gonna explain it my way. So again, okay, here's what it's doing, right? What does ASM this return? Okay, I'm gonna move this here. So essentially what it wants is, what does this, it looks like a function call, right? It's like ASM0 is the function, which is this, right? It's like a label, right? It's labeling all of this code as ASM0, and it's calling the function with two arguments. First one is a number hex D8, second one is a number hex 7A, right? Now, it's what you need to now figure out is, what does this function return? Okay, and here's where I missed the register. There's actually 9 registers. EAX is one of them, so I'm gonna put that in there, right? I don't know why Google said 8, but yeah, I missed a register. EAX is one of them, which is a reserved register as well, and I just remembered, so I'm gonna explain what this is doing. So when you have a function being called, right? Remember I said, if I go back to Paint, when you call a function, it gets its own sort of area in the stack, right? So if I call ASM0, it might get this bit of memory on the stack, right? When that happens, I'll actually go back. When that happens, right? EBP, so if I go back, you have a couple reserve registers here. EBP, which stands for, the E stands for 32-bit, right? The E is there because it's 32-bit, so I'm going to skip the E. BP stands for base pointer. ESP stands for stack pointer, right? So remember, this is the bit of memory region that's reserved for our function. When this function is being called, this is EBP, okay? EBP, the register points to this memory address, right? Remember, this is all just memory, right? Memory address is like just numbers in memory. EBP, the base pointer, points to the base of the function's memory, right? And vice versa, ESP, the stack pointer, points to the top of the stack where the functions, like the top of the function exists, right? Now, without getting into too much detail here, which might be confusing, essentially what it's doing is, if you can skip this part, okay? This is like the function preliminary. So what this is doing is, when you call the function first, it pushes... I'm trying to, because this is going to be very confusing. You guys are not going to understand it when I first explain it. It's just, I'll have to explain it like 3 or 4 times, and I'm not about to do that. So I'm going to just skip this part, right? Trust me, if you guys really want to get into this and learn it yourself, I recommend going through the challenge yourself later on. And you can like message in the chat as well if you get really confused, and ask me, and I'll sort of try to help. I'm going to skip that. The important part here that you want to learn is that EBP plus hex 08 is going to be... So this whole thing, what it's doing is, it's taking EBP, right? So going back here, it's taking this memory address here, it's adding 8 to it, right? So adding would make it go up, right? So it's going further down, right? It's increasing memory, the memory address is increased down, right, from 0 to higher up. It goes down, and then it dereferences that address, right? So in C, you would have the asterisk, right, dereference pointer. It dereferences that address, gets whatever value is there, and moves it, right? Remember, move is source destination, moves this source value into EAX, right, that register. And same way here, instead of hex 8, it's going to be hex C. Hex C is 12, right? And hex 8 is just 8. So it's adding 8, moving that value into EAX, adding 12, dereferencing, and moving that value into EBX. Now, what is EBP plus 8 and what is EBP plus 12? Well, if you go through the tutorial, right, and you really try to understand it, you'll see EBP plus 8 is the first argument of this function, and EBP plus 12 is the second argument of this function, right? If you go through the tutorial and really try to understand assembly, I can give you some resources afterwards. That's not the tutorial. There's a very good book. Actually, I'll just put it up here. It's called, if you go to beginners.re, right? So beginners.reverse engineering. This Russian guy, or is it Polish? I forget. Denis Yurichev, I think he's Russian. Yeah, it should be Russian. He has a Russian translation. He has this amazing free book with a huge number of pages, and it goes through assembly from top to bottom, assuming you have zero knowledge of anything except a little bit of C. He assumes that you know some C, right? So if statements, for loops, etc. Other than that, the book goes through assembly top to bottom. If you're really interested, you can go through that. So I'm not gonna, I'm just skipping a bunch of stuff because it would take way too long. This requires like a whole lecture or two to explain all of this, right? So because I'm skipping a lot of knowledge, you probably need to understand what I'm saying. Either way, we can comment, and in assembly you comment with semicolon, right? Instead of like double slash or like that, right? It's gonna be semicolon. We can say this is argument 1 and this is argument 2. Just comment it out, and then what happens, right? We can say argument 1 in EAX, right? Because it gets moved into EAX, and argument 2 in EBX, right? We just remember this. And now what it does is it moves EBX into EAX, again, source into destination, and then it does a bunch of stuff. Again, this is the reverse of what it did here at the beginning. So with functions in assembly, you have what's called a function prologue, which is what happens before at the beginning of the function, and then you could have what's called a function epilogue, which is what happens at the end of the function, right? It's just terminology. We can ignore this, and it's just in the same way we ignore that. And then it calls ret, right? And remember, the original question was, what does this return? And the other thing, like I said, I added that register at the end, EAX. What you have to know here is when a function returns in assembly, the return value is always stored in EAX, right? So if I go here, I'll comment it, return value stored in EAX, right? So what did get stored in EAX? And this is pretty easy to see. The argument 2 gets moved into EBX, and then that same value from EBX gets moved into EAX. Therefore, EAX equals hex 7a, right? Because that's the second argument. So that's pretty simple. Now, I'm gonna put a disclaimer here. In assembly, arguments are supposed to be in reverse order when being, like, I forget if this is argument 1 and this is argument 2, or if it's vice versa, right? Because I don't really deal with assembly all that often, like direct assembly like this, especially 32-bit, because like I said, modern machines are all 64-bit, so I don't see this that often, so I forgot. It might be vice versa. So the answer is either hex 7a or hex d8, right? It's either one of those. I'm thinking it's hex 7a. So we go back. It says, yeah, that should work if that's correct. It is correct. So again, I'll reiterate, right? I just got the right flag. It's a hex 7a. So like I said, EAX is reserved for return values, right? So whatever is in EAX at the same moment as this ret or return instruction is what gets returned. And if you follow what I just explained, argument 1 is put in EAX, argument 2 is put in EBX, and then it's moved from EBX into EAX. Hence, argument 2, which is hex 7a, is moved into EAX, and then you ignore the epilogue or epilogue, and you just ignore it, and you return. It's the value in EAX that gets returned because that's how the register works, and bam, that's the answer. It's just hex 7a, right? Now I understand that is probably very confusing, because I know for a fact there's someone, at least one person watching that's only doing PDI, hasn't done UCP yet. I don't know if they know NEC, so this is gonna be hella confusing. I hope it at least made a little bit of sense. Like I said, it's gonna take up like hours, probably an hour and a half or 2 hours to explain exactly what all of this means, and you know, it's just I'm not doing that. So you know, if you're interested, you go through it yourself. So yeah, that was the first reversing challenge that, you know, probably would you know, throw you off a little bit. And as you can see, it does make sense that you have, you know, like 12,000, 16,000 solved for all the other challenges, and it just drops straight down to 8,500, right? So that's the best way I can explain it without wasting too much time. Again, if you really want to get into it, PicoCTF 2018, you know, just do it in your own time. We have tuition-free week, tests are getting pushed off. You know, if you have any time at all, you know, that's what you do. Okay, it's already 8. I was gonna stop. I probably will just stop here. I hope everyone enjoyed coming and watching, and you know, hopefully you guys learned something new, and hopefully you guys feel a little more inspired to get into CTFs and learn. You know, like just in general, even if you're not a cybersecurity student, right? I mean, I assume not everyone watching this is a cybersecurity student. Even if you're not, with CTFs, you are learning how to hack, but more importantly, what you're learning is how to figure shit out on your own, right? You get thrown in the deep end, they give you a description of a challenge, they give you some hints, and all you're left with is just Google, right? All you have is Google, and maybe, you know, when you Google, you can, because this CTF ended in 2018, you can find direct write-ups for the challenges, you know, but you essentially try not to look at the write-ups directly, and even if you do, if you get really stuck, always try to understand from the write-ups, you know, how the solve works before you actually move on. And yeah, hopefully, you know, you guys get into it as well. We're gonna continue off from here, or we're gonna do, I'll probably just continue off from here next week. Hopefully it was interesting. Yeah, you know, give it a shot. You know, just go straight into PicoCTF if you'd like. I've showed you a bunch of stuff. Yeah, this is all very, okay, I was gonna say this is all very beginner level, but this obviously wasn't. This was beginner level in comparison to someone that knows assembly, right? Like if you compare it, if you let someone that knows assembly do this challenge, it was very beginner level. But you know, for you guys, for example, this probably taught you a bunch of stuff that you didn't know, and you're still confused. So you know, keep on learning, I guess. That's what being a hacker means. You know, you can be a software engineer and still be a hacker, because, you know, like for example, if you go work at Google, I always like to use this example. If you go work at Google, and if you for example work as a software engineer for their browser team, right, on Chrome, you're gonna have to fix vulnerabilities and bugs, right? So you have to know how to hack, to fix vulnerabilities that lead into hacks, right? So anyway, yeah, I'm just gonna turn the stream off. What is this? That's pretty cool. All right, cool, yeah. So yeah, that's that. If you have any questions, feel free to like general chat or any of the cybersecurity related channels. You know, just mention me, ask questions. You know, feel free to. Yeah, I'm always open to answering or helping people out, right? So yeah, hopefully we'll continue off next weekend, or not next weekend, next Thursday. Yeah, good luck with uni, guys. I know everything's sort of hectic. You know, studying online and stuff is pretty hectic, but yeah, hopefully everything's working out. Yeah, I will see you guys next week. Turning the stream off now. See ya.